What happens when the wind stops blowing and the sun isn't shining? Can renewable energy really power everything, or are we missing part of the story? Today, we're digging into the future of energy, what's real, what's possible, and what it'll actually take to keep the lights on. I'm Lynn Toman, and this is Three Takeaways. Today, I'm excited to be with Dr. Ernest Moniz. He served as U.S. Secretary of Energy and has spent decades at the center of science, innovation, and policy. He's a physicist and is also co-chair of the Nuclear Threat Initiative. Welcome, Secretary Moniz, and thanks for joining Three Takeaways again today.
Good to see you again.
Great to see you. Let's start big picture. Where are we right now in the shift toward cleaner energy?
Well, we're going a little bit more slowly than we would like towards clean energy, but I think one distinction is very important. Often when the word energy is spoken, what's really meant is electricity. And in electricity, we have made, I would say, significant progress towards low and no carbon sources. There's a ways to go, but we have made a lot of progress. However, electricity is, let's say, on the order of a third or quarter to a third of useful energy delivery for our activities today. And if you look at the rest of the picture, sometimes called molecules, fuels, etc., the progress towards low carbon fuels that are affordable and available at scale has been extremely slow. I'd say we're making decent progress on electricity and nearly no progress on affordable clean fuels. Secondly, that division comes into the following statement, namely that the discussions around clean energy and security, which are, of course, quite manifest in this period of the Middle East activities, especially Ukraine as well, social equity, those are really all one conversation. I think it's very important to keep that as a reference frame because I don't think progress will be nearly as fast in any of those three areas if we don't consider them all together. So I think that's the big picture as I would see it. 1/3 full, 2/3 empty.
Can you summarize the numbers, the percentage of energy that comes from fossil fuels, from nuclear, coal, and the major types of renewable energy?
Yeah, so natural gas in electricity is over 40%. That's growing rapidly. It wasn't that long ago that it was 20%. The fastest growing sources are clearly natural gas and renewables. Wind and solar together are now producing, I think, more than 20% of our electricity. And that was quite small not so long ago. We will be adding hundreds of gigawatts, a gigawatt being 1,000 megawatts of renewables in these next years. And of course, that is accompanied by battery storage, especially where the costs have come down dramatically. Coal is below 20%, nuclear is about 20%, gas is double that, and renewables is a bit above 20%.
What is the share of the major types of renewable energy?
Well, by far the biggest is solar and wind. Solar has come up extremely rapidly to the point where it's just about caught wind. So they are both in the 10, maybe 10 plus percent range for electricity. Then you have hydro, which is still substantial. It's about 7% or something like that. And you have geothermal, but this is conventional geothermal, where you've got hot water bubbling out of the earth, like in Yellowstone. And that's pretty small, 1 or 2%. Another technology that produces exactly zero for the grid today, but could be a complete game changer, is nuclear fusion. And a lot of people are betting that in 10 years, you're going to see some fusion electrons on the grid. And yet another possibility is hydrogen from the subsurface, either naturally produced hydrogen. There is some in the world, not a lot. And yet another possibility is the combination of underground engineered geothermal together with hydrogen production in the subsurface, trying to mimic the physics that produces hydrogen naturally in the subsurface. I'm rooting for fusion, especially. I'm on the board of one of the fusion companies, to be transparent about it, but I'm there because I think there's a good chance of it working. And I think we'll know in 5 years whether that dog hunts. And if it does, It's an answer to many, many of our clean energy
Mm.
aspirations because, unlike nuclear fission, no one will raise significant issues of safety. You can site a fusion plant anywhere on the grid. But as I say, those last technologies I mentioned today provide zero to the American grid.
But that is an exciting possibility. How does that break down in the US? You've said electricity is a third of it.
Well, the big issue is transportation, a
Okay.
huge energy use, obviously gasoline, diesel, jet fuel. Transportation is the largest individual sector in the energy economy, 35% or more. Then, of course, there's a lot of industrial use of energy. Natural gas, for example, is a feedstock for many, many energy applications, providing heat for industry, of course,
Mhm.
providing heat for homes. And the energy business is pretty broad, lots of different fuels.
Can wind and solar realistically fill all of our energy needs, or do we need a broader mix?
I believe we really need a broader mix to have a sensible, reliable economic system. The reality is that wind and solar obviously are weather dependent. Their profile can be smoothed out by storage technologies like batteries, for
Mhm.
example. But of course, batteries don't give you more electrons, they just spread them out, which is a good thing, but that is not going to generate more electrons for you. When you look at the details of how the wind blows and the sun shines in various places in the United States, for example, we looked hour by hour for 1 year at wind in Texas. And Texas, as you know, has the largest wind deployment in the United States. The reality was that even with that, there were about 9 days in a row in that year where there was essentially no wind in Texas. That's the way it is with a weather dependent system. Now, that has never really bitten Texas because when all is said and done, gas is still a bigger source of electricity. And so when the wind isn't blowing, well, you crank up the gas, for example. Once you start getting to a much higher penetration, then you have to take care because I don't think a governor is going to be very interested in telling his or her population that, oh, don't worry, it's only 9 days without a lot of electricity. That would not go over well. So the fact is, you will need some backup unless storage becomes a reliable, economical, not only multi-day, but maybe multi-week affair. We are seeing progress, but the reality today is you're hard pressed to make any economic case for smoothing out wind or batteries or solar for that matter for more than a few hours. Maybe 6 hours now is pushed. There are technologies that look very promising that
Mhm.
are reaching the day kind of frame,
Mhm.
maybe 2 days. But I think a solution that you will want, in my view, is to complement the intermittent resources, wind and solar, with so-called dispatchable resources, resources that you can use whenever and basically wherever you want.
I don't think many people have really thought that when we use renewables like wind or solar, that we still need backup when the wind doesn't blow or the sun isn't out. And right
Right.
now, it's primarily liquefied natural gas or fossil fuels. But it's promising that these new technologies are all starting to come online. Even when we do generate clean energy, getting it where it needs to go isn't always simple. What makes it hard to move wind or solar power or other renewable energy from where it's generated to where people actually need it?
The biggest issue is that the greatest resources for wind, it's more or less in the Midwest up the Great Plains. And the greatest solar resource in the United States is, I would say, in the Southwest. But in both cases, you are pretty far from the major load centers, certainly in the East. In the Southwest, there could be some access, obviously, to California in particular. The problem is now you have to move it over long distances, and long distances generally require crossing a state line. This is very hard to do. It's not impossible. Obviously, it's happened, but the times to build out the grid are generally measured in 10 years, 15 years. It's very, very difficult to get projects over the finish line. Secondly, we have not really maintained the level of investment in building a reliable grid in many parts of the country for quite a while. And that has led to major bottlenecks in terms of literally hooking up new power plants. So that's the underlying challenge.
Beyond wind and solar, there are other technologies in the mix. How do you see other technologies fitting into a cleaner energy future?
On the electricity side, I'm a big advocate of fusion. I think today's nuclear power approaches are getting very, very strong bipartisan support and
Mhm.
international interest. There's some really interesting R&D going on enhanced geothermal. Geological hydrogen is a bit of a bigger risk in terms of paying off, but I'm very enthusiastic about pursuing that for sure and finding out because these are big breakthrough opportunities. So there are quite a few there. But again, the big one to me is to get a breakthrough on the molecule side. And one of the more promising approaches is hydrogen. I don't mean geological hydrogen, it could be, but also hydrogen produced from water, hydrogen produced from natural gas with carbon capture and sequestration. Because hydrogen, it's too expensive at the moment, especially so-called hydrogen from water from catalysis. It's got to come down by a factor of 5 in cost. But if that happens, then hydrogen could be a no to very low carbon way of taking up many of the uses of natural gas. It would be a major breakthrough. But as I say, especially the electrolysis route to hydrogen is today too expensive.
Let's zoom out to the global picture. If the US and Europe reach net zero greenhouse gas emissions, is that enough, or will global greenhouse gas emissions still keep rising?
I think they will still clearly keep rising because the contributions from the emerging economies and the developing world are going to grow substantially and outpace the savings in the industrialized economies. So I think the answer is that we would certainly expect some continued rise for a while. But I think this is an important point, and it goes back to the very first point that we discussed, the point about one needing one conversation around security, climate, and equity. The equity in particular, I'm thinking about in terms of the developing world. A lot of the discussion globally around climate change has the unfortunate feature of lapsing into talking about the world as if it was one, whereas different parts of the world have enormously different circumstances, particularly with regard to economic growth, and therefore extremely different priorities. And I think that until we realistically deal with those issues, that sub-Saharan Africa is not going to deal with a carbon problem the same way that Scandinavia does. I think we should find ways in which the wealth of the industrialized countries is invested in some of those economies to have their evolution be more carbon friendly. But the reality is, if you don't appeal to them to meet their priorities, it's
Mhm.
not going to go very well. So I think that's a big issue. And if we take the situation in the Middle East and the Gulf, I believe that one of the consequences will be a long-term greater commitment than would have been the case to coal use in Southeast Asia. Well, India, Southeast Asia,
Right.
China, for security and equity, in the sense that they have become typically pretty large liquefied natural gas importers with the constraints in the Middle East.
Mhm.
The prices of LNG have
Mhm.
gone up sky high in Asia and to a certain extent in Europe,
Mhm.
not in the United States. We don't use any LNG to speak of, and our domestic sources have been remarkably stable in price. But they see their price go up, they see their security threatened. They're building more coal and extending coal plants, running their coal plants harder. So on the carbon front, we'll have a setback there. But that's where we have to have a system-wide view of trying to satisfy the priorities of populations in different parts of the world as we transition to a low-carbon future.
If greenhouse gas emissions are going to keep rising, should we also be focusing on adapting? And what does that look like?
Adaptation is clearly important because we are seeing the effects right now of global warming. But I'm afraid it's time to cross the Rubicon and to start seriously looking at least the research and governance programs for geoengineering, for intentionally modifying the Earth's geosystem to be able to reduce global temperatures in a pinch if we appear to be approaching closer and closer to climate tipping points from which we cannot recover. And unfortunately, there are indications of that. So I would just say that this is a whole additional discussion in and of itself, but I think it's time to be looking at that side of the coin as well. Adaptation, geoengineering, infrastructure resilience, in addition to trying to mitigate the problems.
What do you think are the biggest misconceptions that people have about renewable energy?
Well, I think a lot of people think that it's kind of unreliable. But first of all, when variable renewables are a relatively small part of the system,
Mhm.
maybe up to 20%, the rest of the system can adapt pretty well. And I'm assuming you're including some storage in there. It's really when the penetrations become much, much larger that it becomes a much greater concern to the operation of a stable, reliable grid. But I think the public needs to be made aware of how renewables are growing very rapidly by business decisions. I think that's the key. That sure, there is some of that growth is from policies like state renewable portfolio standards and the like,
Mhm.
but a lot of it is just being driven by business decision. Like when the hyperscalers want to feed their data centers, soon they're looking at gas and renewables and batteries as the relatively short-term solution. In the longer term, they're very interested in nuclear and fusion and engineered geothermal, et cetera, but they're not counting on any of those for 10 years.
One of the interesting changes that businesses are now focused on people, their employees, their customers, their brand value, and they increasingly are focused on being more environmental as opposed to emitting huge amounts of greenhouse gases or polluting the environment. Secretary Moniz, what are the three takeaways you'd like to leave the audience with today?
So, in the first takeaway, we need to focus on one conversation in terms of using energy development and clean energy to address security, climate, and equity at the same time. The second takeaway is that electricity, very, very important and increasingly important as we electrify more parts of our society. But the reality is, it will not be even the majority of energy use for a long time. We cannot forget that still most of the energy economy operates on fuels, and we have made relatively little progress, to be honest, in replacing those fuels at very large scale, at very low carbon, and at very affordable prices. And a third issue is regionality, that the solutions aren't the same in different parts of the world. Frankly, they're not the same even within different parts of our country.
Secretary Moniz, thank you for your service in government, and thank you also for returning to three takeaways to help us make sense of a complex but very critical topic.
Thank you.